Alright guys, so today we are going to be starting chapter 6. And so we're going to be really heavy on math, and it can be a little tricky. These can be some of the harder chapters in chemistry because of that math. So if you are struggling or need anything at all, just let me know and I'll help you out with whatever you need. Alright, so to start off here, it tells you guys to, let me put this up real quick, there we go. It tells you guys to draw the boxes from the periodic table for sodium and chlorine. So just boxes here, and then it tells you to label the numbers. So the only numbers we truly care about, there's two, are the atomic number and the mass number. So for instance, sodium is Na, and it's 11 up in that corner, and then we're going to round. When we do all of this math, we will round. So sodium is really 22.99 or whatever, but we're going to round to 23. So then it says to label these. So label this your mass number. And that is your atomic number. Okay, so that's for sodium. So now let's do chlorine. Chlorine, and its atomic number is 17. Now its mass number is 35.4527. Now this is one of the few that I won't round to a whole number. Some kids do, and that's fine. Your answers are just going to be a little off from mine. As long as you show me your work and I can see that you've set it up right, like I'll know why it's off a little bit. But I will always keep this at 35.5 because it is almost directly like 35.5. So I don't want to round up. Technically, you should, if you're using the board here, you'd round up to 35, or round down to 35, but you're almost halfway there, so that's why I do that. Once again, the 17 is your atomic number, your mass number is 35.5. So then once the kids do that in mass, then what is the mass of one sodium atom? Well, if you're using those boxes from above, it says that sodium is 23. Now, we will, at the beginning of this chapter in the book, they call them AMUs, which means atomic mass unit. Now, we'll see that throughout this chapter, about midway through, they will stop using AMU and they'll switch to just plain old grams. They are the same thing. All right, so if I say 23 AMUs, it's interchangeable with 23 grams. But I'm going to stay true to what section 1 does in this book. All right, so what is the mass of one chlorine atom then? If I'm looking at chlorine, it is 35.5 atomic mass unit. All right, so then once I have that, I'm going to ask them, so we can conclude that the mass of sodium chloride is what? Because sodium chloride is NaCl. So then what's the mass? And usually kids will pretty quickly tell me that we're going to add these two together, which would make 58.5. So we did that by adding my sodium and my chlorine together. Okay, once again, AMU, atomic mass unit. So we're going to do some math practice then with this. So I know that one sodium is 23, one chlorine is 35.5, and I know when I put them together, one sodium chloride is 58.5. So the math practice says, okay, well, what's the mass of 20 sodium atoms? So I'll look at the kids and I'll say, okay, we have 1 equals 23, so how much are 20? And they'll say we need to multiply. And I'm like, okay, so we'll multiply them. So if you took 20 times 23, you're going to find that that gives you 460 AMUs. Right? That would be like me having a penny and weighing a penny and then going, okay, well, how much is the rest of these penny? Like, how much would 100 weigh then? All right, what is the mass of 1 times 10 to the 8th sodium atom? So let's look at number 1. When I ask what is the mass of 20, we multiply it. I'm asking again on number 2, what is the mass? Yes, it's a strange number. It's a very big number. Get used to that in chemistry because all of these particles are so small that when we're counting them, there are a lot of them. So we're still going to do the same thing as what we just did. We're going to take that 1 times 10 to the 8th, and we're going to multiply it by what one of them weighs, which is 23. Now when you do this, you put this in your calculator, you're going to get 2.3 times 10 to the 9th. Atomic mass unit. Start to dot up down there. Okay, so I'm going to erase this, so if you're still writing or need any time, pause it, come back to the video. Okay, has a mass. Now look, number 2 is asking for a mass. Now in number 3, I'm telling you what the mass is. So the mass is 354 AMUs. Same as grams. How many atoms are there? So I'm asking you the exact opposite. So normally when I throw it to the kids like this and I tell them, hey, I'm asking you the opposite of what we did in number 1 and 2. What's my math going to be? Right away they'll know that it's division, which is true. So I'm going to take 354 and divide by sodium's mass, which is 23. Right? So when I do that, I'm going to get 17.7. And that is atoms. And how I know what units, look, it says how many atoms. So that's what I'm looking for. All right, so on number 4, same thing. If I have sodium chloride that has a weight. So once again, I'm giving you a weight, and I want to know how many atoms. It's the same as number 3, so I'm going to divide. So it's me saying, hey, 1 sodium chloride weighs 58.5, but I have 546 AMU. So how many sodium chlorides do I have? So you would take 546, and you're going to divide by 58.5, which that gives you 9.3 atoms. All right. Now then, if you're not sure, like some people will get that right away. Some people will know, hey, I have to multiply. Some will automatically know, like, hey, I'm going to divide this. Some don't. Some are, they struggle a little bit with math and they need that little extra help. Not only that, but when we get further into this chapter, even my best math people that I've seen in the past have needed to use the parentheses. And I know kids kind of cringe when I say that, but I've had kids fight me tooth and nail and be really great in math, and in the end they end up doing this because it just helps out. It helps keep things straight and know exactly what you're doing. All right, so I'm going to clear the ink. All right, so if you're not sure, here are the steps. So first, you're going to determine what information they give you to start with. That's step 1. What do they give you? You're going to write that down. That's the first thing you're going to do. Second, then you're going to make sure that the units that they gave you that you're starting with, that they go on the bottom of your conversion so that you can cancel them out through division. So an example from up above, I'm going to do the first one. So they gave me 20 sodium atoms. So my first step tells me to write down what they gave me. I need to make sure I label this, use my units. Now, I don't care if you want to abbreviate, whatever makes sense to you. You could put NaA, like sodium atoms. You could put just 20. If you know what it means, you could put just 20 Na, something like that. All right, I'm going to do sodium atoms because I want to make sure that everybody that's following these notes knows exactly what I'm doing. Okay, so once I do that, step 2 tells me that on this conversion, I'm going to put the units I started with, which are sodium atoms. I'm going to put those on bottom because that's going to cancel out through division because, right, I don't want my answer to be in sodium atoms. I want my answer, in this case, to be in an AMU. So that's what's going to go on top. So these cancel out. Now, I'm going to use this conversion from above. You guys told me at the beginning, or maybe I told you in the notes, that 1 sodium atom is 23 AMUs. Now, anything that is on bottom, you are going to divide. Anything on top, you will multiply. If there is a 1 on top or bottom, it is not going to change your answer, so I ignore the 1. Sometimes that confuses kids. They're wondering what I'm doing with that 1. Well, you don't have to do anything with it, so I just ignore it. So all I see when I look at this is, hey, I'm going to have to multiply 20 times 23, which is 460, and that is exactly what we did up above. So let's do a division one then. So let's look at number 3. Number 3, I'm going to, my first step here, it tells me to write down what they give me, which is 354 AMU. Then I'm going to do my parentheses. I'm going to put my AMUs on bottom so they can cancel out through division, which means my atoms have to go on top. Now this is AMUs for number 3. That was for sodium. Alright, so then 1 atom of sodium weighs 23 AMUs. So right away, that 354, I know I'm going to have to divide by 23. The 1 I ignore because it's not going to change my answer. If I take 354 divided by 23, it's going to give me 17.7. Then I would multiply by 1 on the top. Keeps it at 17.7. 17.7 sodium atoms. All right, so you will see me, and I will be very, very like vocal about using these parentheses, using your conversions, because right now you may think, oh no, I have this, but wait until the end of the chapter when you're doing 3, maybe 4-step problems at a time. That's where kids sometimes they start trying to do it in their head, and they struggle and they mess up. So when you get something where you're like 20 sodium atoms, and then you're like, oh, okay, I've got 3 parentheses now. If you don't write that out, it's real easy to get that, to lose track of where you're at. All right, so let's do the learning check. The learning check says, what is the mass in AMU of 75 silver atoms? Now this is amazing, guys. I know, and I cannot say this enough. I have kids every year fight me tooth and nail with this conversions, but this is something I use in everyday life. I use conversions all the time. It doesn't even have to be chemistry related. Like, I use conversions a lot in life. And what helps me is this fact that I know that whatever I have, whatever they give me, is what I'm writing down. And then I'm like, okay, I know that's got to go on bottom, so I can cancel it through division. Then I ask myself, what am I looking for? What am I looking for? And I'm looking for mass, AMU. Okay, so then I'm like, okay, well, when you get that, anytime you need a mass, you're going to look at your periodic table. Always, that is where you're finding these mass numbers. So if you look at your periodic table, silver's mass, if you round, is 108. 1 atom of silver weighs 108, right? So this tells me right away that I'm going to be multiplying 75 times 108. Because I rounded, I get 8100, which then my answer is going to be number 2. Which is fine. Like I said, I don't care that you guys round. If you round a little bit differently than me, at least show your work. I'm really big on showing your work because I will give partial credit on problems. You do not know how many times a kid has set this up exactly right. They have it set up 75 with the 108 on top and then give me a different number. Like the answer's wrong. And you would only lose half a point if you have it set up correctly. All right, next learning check. How many gold atoms have a mass of 1.85? So I'm going to write down what they give me. That was the first step. AMU, so my mass, which means my mass then has to go on bottom. And I'm looking for atoms. Now this is a gold, so I'm going to look at the periodic table. Remember, mass, always off the periodic table. Gold is approximately 197 atomic mass units for 1 atom. So this tells me I'm going to divide, right? These cancel out. So this is 939. So number 1. All right, and then the last learning check kind of takes us back to chapter 5 a little bit. It says, using the periodic table, calculate the formula mass. So when I'm asking for mass, I want to know how much it weighs. And a formula, it means that it's not just gold or just silver. Like, it's a formula, which means there's 2 elements stuck together. And in this case, it's aluminum sulfide. But it says, first, let's practice chapter 5. What is the formula for aluminum sulfide? You look at your periodic table. Aluminum is a metal. It's on one side of the stair step. And chlorine is a non-metal. So a metal and a non-metal is going to be ionic. And when we have ionic, that's an ion, which means we have charges. Okay? That means we've got to crisscross these charges. These charges need to cancel out and equal 0. So we do that very easily by crisscrossing these. A 3 would go to the sulfur. All right, so now look at this. A plus 3 minus 2, look at this. Negative 6 plus 6. Our charges equal 0. So now to find how much this thing weighs. Well, I need to look up and see how much does aluminum weigh. And aluminum weighs approximately 27. So I'm going to take 27 times 2, which equals 54. I'm going to put an X here. That's multiply. Sulfur is approximately 32 times 3, because there are 3 sulfurs, which would equal 96. So my total is going to be 150 atomic mass units. Now remember, at some point we'll change that to grams. But the formula, let's make sure we write that there. Okay, so at that point we would stop our notes and I would tell the kids, okay, knowing what we know, knowing about how to figure this stuff out and the math we just did, I'm going to give them a challenge, and there's going to be some salt at their desk, and of course we have the sinks here to get some water. But I just want to walk you guys through that. Obviously you're not here, you're not going to be able to do it, but I would say bring me 5 sodium chloride atoms, show your work below. Alright, so now when people think of atoms, they think of like something big. Like I can't see, basically there are a lot of particles. There are a lot of particles in an atom there. All right, so when I say 5 sodium chloride atoms, so 5 NaCl atoms. Now look at this. I'm going to put 1 NaCl atom on bottom. Now the reason I put 1 is because I need to know how much does one of these weigh, but that NaCl atoms go on bottom because I need those to cancel out. So now my mass, this is how you're going to bring this to me. You're going to have to weigh it out in one of my scales here. Sodium chloride, we said, is 58.5. So students would have to take 58.5 times 5, and they would get 292.5 AMUs. So they would go and weigh out approximately 293 grams of salt, and then they would bring it to me, or they would raise their hands and I'd come over and check. Then I would have them, after they get done with that, I'll say, okay, now do the next challenge. It says bring me 10 water atoms, right? Show your work below. So let's see here. We're going to do 10 now water is H2O, right? They got to figure that out first. 1 H2O is, let's see here, and now this is atomic, so atomic mass units are a little different. Right now, normally atoms are really, really tiny. So atoms are representing something else right now. We'll talk about that later in the chapter. Water, if you look that up, oxygen is 16 grams, hydrogen is 1, but there are 2 of them, so it's really 18 AMUs. So basically what I'm looking for is for them to weigh out 180 AMUs or grams on the scale and bring it to me. All right, and then that would be it. So that is section 1. Once again, we're starting out very, very simple, just how much does this weigh? Eventually, we will get into multiple steps with this thing. So if you are struggling at all, you need to let me know so we can get it figured out before we move on. All right, if you need anything, let me know. Have a great day. Bye.